Hi, welcome to this question on leaving cert differentiation. Here we're asked to find dx dt and dy dt of these two quotients, and we're to use our answer to find dy dx. That's parametric. So let's remind of the two main ideas in this question. Part 1 involves using the quotient rule to find dx dt and also the quotient rule to find dy dt. There is a chain part in that as well. And the second part of the question, we're going to be using parametric differentiation, and there's a formula for that. Let's start by trying to work out dx dt and dy dt. So dx dt, we'll use the quotient rule, and the formula says it's v, that's the part in the bottom, t plus 1, multiplied by du dx, the derivative of t minus 1, which is just 1, minus u, which is t minus 1, multiplied by the derivative of dv dx, which is the derivative of t plus 1, which is just 1. Okay. And everything is divided by v squared, which is t plus 1 squared. Now we neaten up the top. We multiply this out and we get t plus 1 minus t plus 1. Be careful with the signs here. Minus by minus gives me plus 1. All divided by t plus 1. Don't try to multiply it at the bottom. And here we see that t minus t is equal to 0. So we're just left with 2 on top and t plus 1 to be squared underneath. And that's our answer. Now we use also the quotient rule on y to find dy dt. So the formula says it's v, which is t plus 1 to be squared, by u, which is du dx, which is minus 4, the derivative of minus 4t, minus u, which is minus 4t, by the derivative of t minus 1 to be squared. Now we use the chain rule on this, and it becomes 2 into t plus 1, all to the power of 1, multiplied by 1, derivative of the inside. There's no need to write that. And that's all by t plus 1 squared squared. Now when you square something squared, it becomes to the power of 4. And we multiply this out, so when you do, I expand to t plus 1 squared minus 4 and multiply this out. Now I'm going to do this quickly to show you the answer. And just when I multiply it out, you see, I'm going to expand to t plus 1 squared, and I'm multiplying minus by minus, which is plus 2 4s, which are plus 8t by t plus 1. That's where I'm getting 8t squared plus 8t, that should say. Now I'm just going to multiply the minus 4 into this. And this is what we get. Notice here I have a minus 8t and a plus 8t, and that gives you 0. And I'm going to add 8t squared, take away 4t squared. That'll give me 4t squared instead of minus 4 all over t plus 1 all to the power of 4. Now if I factorize the top, I notice that the top is actually 4 into t squared minus 1 all over t plus 1 to the power of 4. Now this is where we get really clever. We should recognize that t squared minus 1 is the difference of two squares. So that actually can be written as 4 into t minus 1 by t plus 1. And underneath the line I have t plus 1 all to the power of 4. And I have a t plus 1 above and below the line that will cancel out. So this now becomes 4 into t minus 1. One of these cancels out with 1 into 4, so I'm left with t plus 1 to the power of 3 underneath the line. And that's the neatest way I can write dy dt. Now let's neaten up our answers, see what we have. So in part 1 we have the dx dt is 2 over t plus 1 to be squared, and dy dt is 4 into t minus 1 over t plus 1 to the power of 3. Now can we use this to find the second question, which says hence find dy dx and express your answer in terms of x. Our parametric formula tells us that what we want is dy dt, which we have, multiplied by dt dx, Well, if the x dt is 2 over t plus 1 to be squared, dt dx is the inverse of this, t plus 1 to be squared all over 2. And this is what goes into the formula. So dy dx is equal to dy dt, 4 into t minus 1 all over t plus 1 to the power of 3, multiplied by dt dx, t plus 1 squared all over 2. And here we see we have some nice cancellations. 2 goes into 4 twice, and t plus 1 squared and t plus 1 to the power of 3, well, they divide in such a way that I'm left with just t plus 1. And when I neaten up my answer, this gives me 2 into t minus 1 all over t plus 1. Now the question said write your answer in terms of x. Well, x is t minus 1 over t plus 1. That's what I have here, 2x. So the answer is quite nice at the end. Probably lets you know that you're right.